Hi, this is Tim. Previously, I put out a PLC quiz question about how to program a lead lag pump setup. And I wanted to come to you with my answer today. Now, I'm getting some great suggestions on this, so keep them coming in. But just a review of what we were doing is we had a low alarm float, a stop float, a lead float, a lag float, and a high alarm float. And so right now they're all off, which means our low alarm float is down. And so we have a red light flashing to indicate that we have a low float. And we have a blue buzzer because I didn't put a buzzer in this trainer. The first thing is while we're here, we should be able to silence our buzzer with the blue button. And we do. All right, we come up off of our low float as our tank starts filling, and that alarm goes out. And then we come up on our stop float. Nothing should happen because it is just functionally a stop float. And now we're going to come up on our lead float, and one of our pumps should come on, which in this case, it is pump 1, represented by the green light. And we hope our tank starts going down so it goes back off. And then it'll continue running until the stop float goes down, starts filling again, stop float comes up, nothing happens. And now our lead float comes up again, and this time pump 2 comes on because that's going to be our alternating setup. Now we can't keep up, so it keeps filling with water, and now our lag float comes up, and the second pump will come on. And if we keep filling up, then eventually our high alarm float comes up. And for the high, our light was solid compared to flashing on the low float alarm. And again, we have our buzzer, which we can silence with the blue button. And then it comes down. One, if it goes back up now, our buzzer comes back on. We can silence again. We hope that it starts going down and our water starts draining. And both pumps now will stay on until either the stop float or the low float goes off. So let me show you the logic I came up with to do that. First, as promised, I did program this in ladder logic, function block, and structured text. And we have switch 4 to switch between the languages. To the right is structured text, the center position is function block, and the left position is ladder. And we can see the basic logic that I'm using to do this. So input 9 is switch 4 to the left. It's going to make the ladder run. The center position, you're not going to have either switch on, and that's going to run our function block program. And to the right, that's going to run our structured text. Now, in our previous PLC quiz, we did some innovative logic to interlock these to make sure that one didn't affect the other when we were transitioning. I didn't say to do that on this one, so I didn't either, hoping to get a few issues, but actually it ran really well because I used really consistent code between the languages. Let's take a look at our ladder logic. And the first thing I'm going to do is I'm going to figure out which pump is my lead pump. And there are numerous ways you can do this. You could do this with counters, you could do this with adds, but this is your basic toggle, or a lot of people will call it a flip-flop. And I'm doing it based off the stop float going down. Going back to our really basic 3-float setup where we have a stop, lead, and lag, I'm using the stop float going down to do this alternation. And you'll see some people do it with the lead, and there is an issue with that. Let's say the water's coming up and we hit the lead float, and that determines which one is our lead. Maybe we start pumping down and maybe we get an inrush of water in, and so it comes back up on that float a second time, and all of a sudden you'll see the pump switch midstream. So that's why I use the stop float going down, because at that point both pumps are off and we can do the transition. And it keeps you from getting that headache occasionally if you're getting surges of water. So every time the stop float goes to a 0, we're going to use a 1 shot to capture that moment. And then, if we see that 1 shot and pump 1 is not the lead, then we're going to put a 1 in pump 1 lead. And of course, the next time this comes around, this pump is going to be false because this alternate 1 shot is only true for 1 scan. And that's going to make this lower one true. And if we got a 1 there that time, that'll seal that in. And let's run rungs 0 and 1 through this logic a few times just so we can see that. And I'm going to simulate that just by switching switch 1, which is our stop float. Our stop float is off right now and pump 2 is not the lead. I'm going to switch the stop float on, which will represent it going up. And you see nothing happen to pump 2 as lead. Now watch it when I switch it off. Off. So now pump 2 is lead. I want to make the float go back up. Nothing happens to pump 2 as lead. And now I'm going to drop down again. And it's going to alternate back to pump 1 being lead. So this 2-rung setup is really common for alternating a pump. So next we had our pump 1 logic. And so if pump 2 is not the lead, that means that pump 1 is the lead. So if we have our lead float, and pump 1 is not the lead, and our stop float is up, then we're going to run pump 1. We'll also run it off of the lag float as long as the stop float and low float are up, and the high float. So really the only difference in the lead lag logic is this pump 2 lead bit from our previous 2 rungs. So right now, pump 2 is not the lead. I'm going to bring it up on the stop float, and now we have that. And so it's only waiting on our lead float to make pump 1 run. I switched the lead float, and now pump 1 is running. All right, and down here we have a seal in. And this is going to keep it running now because this is output 0, which is also here. And that'll keep it running as long as neither our stop float or our low float go down. So I switch the lead float back off, and pump 1 keeps running. And now I can drop either of these out, and it's going to make this rung false. So there we go. And this one works exactly the same way. Well, first, no, let's go through this one again. Because now pump 2 is lead, and you can see that down here. So we come back up on our stop float. And last time, this upper branch here was what we were able to run this pump off of. But now when I go on my lead float, you're going to see pump 2 come on. And so that's what's preventing pump 1 from coming on now. Now, they're identical besides really is pump 2 lead here. This is looking for a 0. This is looking for a 1. All the rest of our logic is identical. So we come up on our lag float, and now pump 2 runs along with pump 1. Next, we have a basic flasher circuit, and I should do a video on this because, one, we can have a single timer, and that can be a sample rate timer. We can have 2, and this is our basic flasher, just like we're using here. But also, this is what we call cascading timers. And so I could have multiple timers to stagger the starting of the motor. So I should put this on the list to talk about more. Basically, these 2 timers here create a 1 second on, 1 second off flasher. And then we have our alarm light, and it's supposed to illuminate solid when the high float is up. So I'll switch the high float on. And when you see that makes it solid. And then if we have a 0 in the low alarm or it's down, then it's going to flash on and off in 1 second intervals. And that's why you see the flash on done from up here. And then we have our alarm buzzer. If the high float is up or the low float is down, we're supposed to buzz as long as the alarm silence is not on. And in this case, our alarm silence, what I'm doing is first I'm looking at these exact same 2 conditions here to figure out if I can seal in my alarm silence. And then whenever we press button 1 and we actually have an alarm condition, then I'm going to write a 1 to my alarm silence. And then I have a seal in around this button, which will keep it in as long as we still have an alarm. So that's how my silence works. Now let's look at it in function block. And one thing I'm realizing is I really need to work on making my function blocks more organized, because as I look at this, I can follow it, but I just feel that I think I've missed some efficiencies, and I've missed some documentation, definitely. But I went off of very similar logics. So here we're looking at the stop float, and we're getting a 1 shot falling. So that means whenever this goes to 0, we're going to alternate our pumps. And if we look back at our ladder, that's the same thing we have here. We have a go look for a 0, 1 shot, alternate pumps. And I used the exact same bits, hoping to have some learning opportunities, but they actually didn't pop up. If we're alternating pumps and pump 2 is not lead, then we're going to make pump 2 the lead. But even as I look at this, if you actually compare it to the ladder, it is the same as this right here. But I just feel I missed some efficiency. So I'm hoping somebody really posts some good function block code for this. And same with this. Now, one thing I needed to do is I should have probably had some text boxes in here to document what it is. But really, and this could be because I just run into ladder more, I can look at this and cleanly understand it. I can't really look at this and cleanly understand it. And it could be that if you do function blocks all the time, you look at this and you're like, yeah, this is really obvious. But for me, I don't know, it just didn't seem that obvious. But this does the same logic. If our lead float is up and pump 2 is not the lead, that's going to be one of our OR statements, which is the exact same thing as the branches that you see down through here. So each time we have a branch, it is an OR statement. And that is what we're doing over here is we're ORing these 4 conditions together. So if the lead float is up and pump 2 is not the lead, or the lag float is up, or the high alarm float is up, or pump 1 is on, then we're going to run pump 1 as long as that and the stop float and the low alarm float is on. So right now to run this, we need 1s in all these boxes. And why do we have a 1 there and a 0 there? Oh, because remember, I have a switch to actually switch between our languages. Right now we're in ladder. Let me switch it over to function blocks. And now let's have a look at it and see if it looks a little clearer. So yes, we need 1s in all these boxes to make this run. And so right now we need a low alarm float, so I'll switch it on. So it's come up on that. Our water level continues to rise. And next we're going to see our stop float. Switch that on. And then we're looking for 1 of these conditions. And right now, pump 2 is not the lead. So as soon as we bring this lead float up, this will be a 1 right here. And that will put a 1 right here. So I'm going to switch it up. And that gives us a 1 there. And our pump comes on. And now I'm going to pump it back down, which is going to make this one a 0. But notice now pump 1 is running, which is going to make this still true. So we got a 0 there, or a 1 here now. And now, again, as long as we have 1s in all these, it'll continue running. So we're waiting on either the stop float or the low alarm float. We drop down and pump 1 goes off. Also notice now pump 2 is lead. So it's going to do the exact opposite. Again, I'm not real happy with this. I don't think this is extremely clear. And really right here is where I started to realize either I just don't look at enough function blocks or I really need to work on how to cleanly write them. Because this is the one, the flash on and flash off, I really felt I should have been able to put the flash off right behind here and make these drive instead of using the function block on and function block off dones. But when I tied these together, it looked really sloppy. And I just didn't like it. So I backed up, I added some function block dones. I mean, because if you look at this right now, this flash on function block done is this flash on function block done. So I could put a connector from right here to right here. But when I did it, it just really, it looked really garbled. I don't know. I mean, in fact, let's do it really quick. This won't take but a second. So I'm going to edit my flash on and flash off logic here. Because this flash off function block done bit right here is right here and right here. So I can delete this out, and I can delete this out, and I can delete this out. And I can put a connector from right here to right here, and a connector from right here to right here. And then I can do the same thing with the flash on. I can delete that, I can delete that, I can delete that. I can put a connector from there to there. And I can put a connector from there to there. And then I felt I should be able to drag this somewhere and make this thing look clean. But I don't know. Every which way I drug this thing, my lines just seem to be very confusing here. And so I didn't like that. And that's why I added these flash off and flash on function block dones, to clean up my code. Now I also could have used the output wire connector and the input wire connector, but in the end I don't know, I didn't like it. So that's what I ended up with, and now let's go look at my structured text. I did do better documentation than last time, and just to show that it works, I'm going to switch forward to the right position, and all of these are off. Water will start filling, our low alarm float goes up, and then our alarm light goes off. Our low float goes up, nothing happens. All right, our lead float goes up, and I believe this time we will be on pump number 2. So pump number 2 goes on. We start pumping down, and the lead float goes off, stop float goes off. We come back up on the stop float. This time pump 1 comes up, and then let's say it's still filling, pump 2 goes up, and if it gets too high, our alarm goes on, and we can silence it. So it does work fine. And this code, even when I look at it, I hear people all the time argue structured text and ladder logic. To me, and I don't know if it's just the way my brain works or what, but this looks exactly the same to me. But all right, first I did do some comments, and I did them in different ways, just, to show a few things I see. Is first right here, I say the next 7 rungs determine which pump is lead, alternating each time the stop float goes down. And this works great until I go in here and I edit a rung, and I'm going to put a comment right here, which if you didn't know, 2 slices, you can put a comment, and let's just subscribe to Tim Wilborne. And that's a comment, and now I put that in there, and I've totally messed up the whole next 7 rungs comment, because now it's the next 8 rungs. But that is something I see. But this is my alternating logic, so when pump 1 is a 0, we're going to do our alternating. This in the end is the exact same logic we used in ladder. Then this time, instead of using the next 7 rungs, I put begin logic for pump 1. Also, I used a different type of comment here, just so you know you can do it, as I use the open parenthesis star, and that makes everything a comment until you see the close parenthesis star. So it's a way you can make multi-line comments. This time I said begin pump 1 logic, and down here I have end pump 1 logic, which kind of helps me see that, okay, this is my pump 1 logic. And let's go through pump 1's logic, and I'm going to compare it mainly to our ladder over here for pump 1, just so we can see that they are the same. So if local :1 I.data.2, which is input 2, and I'm going to call that input 2 from now on, is a 1, and not pump 2 is lead, and okay, if you don't know, pretty much this is saying, is it a 1? This is saying, is it not a 1? And over here, we've talked many times, this instruction goes and looks for a 1. And this one goes and looks for a 0. So if something's not a 1, it is a 0. So this is the exact same logic. Now right away, you'll notice here we have a description of lead float. And structured text, you don't get that option. But we can mouse over it. And right there at the bottom, you do see its lead float, so we do get a little picture of it. And next we have an OR. And we just said that these branches right here are ORs. So we have OR input 3, OR input 4, OR output 0. And over here we have OR input 3, OR input 4, OR output 4. And input 0 and input 1. Well, anything you put in series in ladder logic is an AND. So we have AND, input 1, and input 0, go right a 1. And that's the same thing we have right here. If all that's true, we're going to go right a 1. Else, which means this statement up here is false, go right a 0. And then end if. And I got end pump logic. Now, one thing I don't know if you know you can do is this little glasses right here. Maybe it be the most amazing thing to be added to Studio 5000 for structured text is toggle inline value display. If we click it, we'll get the actual values of these. And programmers don't seem to like this because it really messes up their program numbers, but when I'm troubleshooting a machine, this is amazing. So we're looking for this to be a 1. And I have a 1. Not pump 2 is lead, which means it's a 0, and I have a 0. And input 3 is a 1, which I have a 1. Or input 4 is a 1. Or input 0 is a 1. So we've got everything we can see right here. We're going to have a 1. So if we're trying to figure out how to stop this right now, we've either got to make all of these zeros, or I've got to make this one 0 or this one a 0. And in this case, this is our stop float, and this one is our low float. So making either of these a 0 will turn ours off. So I'm going to do that. So I'm going to switch our stop float off, which you'll see right here. This is going to go to a 0. And that makes all this 0. So again, I don't think I would get really excited about seeing all my inputs and outputs in structured text, but with that toggle in line, it is possible. I'm going to turn it off just so we can look at some of the program, because I'd mainly worked on some different ways to document that I see. And again, I told you in the last PLC quiz, my documentation needs a lot of work in structured text. And obviously we see in function block, I either need a lot of work or I need to work with it more so I just recognize things right away. But this is my pump 2 logic. Made it very similar to pump 1. So I've got a begin comment, I've got an end comment, and that tells me where that logic is. Here is my flasher, and if there's ever one that people complain just really gets bloated in structured text, it is the flasher one. So from right here all the way down here, that's our flasher logic. And yes, in ladder logic, I can do it with these 2 basic rungs right here. But these 2 basic rungs are replaced by this. And maybe somebody knows a smoother way to do this. Like I said, I'm not that strong at function blocks or structured text, but this is what I came up with for it. Now, I did do a few other things on commenting down here just to show that it could be done. And I don't see this done often because I think it's too much work on programmers. But we can use that per open parentheses star and then a text and then star close parentheses to put comments in the inside of our code. So instead of just saying local :1 I.data.0 and having somebody having to mouse over to figure out its alarm silence, I put that it's blue button right here. That way we know what we need to hit. And same here, I put the high float in and I put the low alarm float in. And I think that does help it out, but I don't see that done very often. That's what I came up with for my lead lag logic. I have really enjoyed seeing your submissions and keep them coming, because as we share with each other, we both learn. And we'll probably do some more of these, so make sure that you have subscribed to our channel and hit that like button on this video. Till next time. Hi, this is Tim.
And this is Amber with TW Controls. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like these.
When you're ready for some intense training, check out our PLC lab.
And if our videos have helped you out, but you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!